Hello, good morning. Hope you are doing well. We are going to learn how to do multi-culinary tests with Python software. Um, then when you open your Python screen, whatever you can just see from my screen is what we will be doing, but we will start from scratch, step by step, and you will see what you will be doing, and we will learn from it. Then at the end, we will get the result like this one here. As I was just saying, we want to do multi-culinarity test to among those independent variables to see if you are suspecting any perfect culinarity among them. Then the result will be given like this as the way you can see it. But previously we have also many things above. Let us now delete whatever we have here and start from scratch. Yeah. To do whatever you are just doing here as analysis, you need to import data, okay? And you need also to import some packages or modules which can allow you to proceed on doing all those kind of things. Then we will be importing the first one, which is pandas, imports pandas, okay? Pandas around here will help us to import our data, or if we want also to structure our data, pandas will help us to do that, import pandas as PD. And after it, we need also, okay, we need also to import the matrices from part C. Part C is a module or around here also. And from it now, we want to import the matrices. The matrix will help us to make good structure of the independent variables where we want to check the presence or not of the multicollinearity. Then let us run and see what will happen if up to now everything is okay. Okay. Then after it also we have to import variance inflation factor, VIF here, which we will be using. Then from stats model, stats outliers influence. Okay, import. Variance, inflation, a factor. Yeah, that is, then we can run and see if everything up to now are okay. Okay, that's okay. Then now let us import the data we want to use, for example, around here. Call it data. And now pandas will help us to import it. And we will say read CSV because the data I'm using is CSV format. And from there, we can now import our data. From there, we will go from your computer where you have your data, you will go to that one and click on it. And now right click and the properties, we will just copy the location of the data and also bear in mind the name of the data. Now from here, if you copy this one, we'll go and paste it on our Pythons. And now from there, we can now add just the name of the data, which is which one around here, CSV. Then let us now to run and see if everything is okay. Okay, we have this one. Then let us try to see our data, how to look like. And we need to print it, print data. If you want to print everything, just print data. And you will come, you will see how our data look like. Or maybe if you want just to print the first 5 lines, you can also print data head now. And from it now, we can now just run again. Okay, everything is up to now, everything's okay. Why are we doing this kind of things? To see the structure of our data. Because now, as I was just telling you, yeah, we can see which one is quantitative, qualitative, or whatever, and so on. And now, the multicollinearity is checked among independent variables when we want to run our model or regression, whatever. But there are specific cases when we are using multivariate analysis where we can also check the perfect collinearity among dependent variables. Yeah. Then here we need also to structure our independent variables by using the matrices. But let us do that. Yeah. Yeah, I say structuring independent variables. Mhm. Okay. Then we will say y x the matrices, and from there now we'll use education as independent variables here, experience as independent variable here, and name it as independent variable around here also. That's okay. Then meaning that we'll be checking, what we'll be doing is just to check the multicollinearity or perfect collinearity among education, experience, and NIMDIP. We can add another one. You can also add which one again? You can add SMSR. Yeah. Then after it, now we need to say that we are using data, which is called here data. The name of our data is data around here. And also we want it to be written as data frame and the return type, return type data frame. Yeah, that's okay for now. Let us also run and see what will happen. Okay, then we can now start to talk about VIF from our data frame. We want it to be PD, like a data frame. The presentation should be like data frame presentation. That's what we are doing now. We want our result, the result when it will come to be like data frame. The presentation should be like data frame. Then we are just defining it like this. And now from it, we want the columns, the first column, for example, to be called variables. Then we will say variables. Okay. And we will say that take the columns names there from our dependent variable. So what I'm doing now, x columns. And now we can now proceed saying that when the result of our VIF will come. Okay, we want to even put it, we want the name of this column to be called VIF also. Yeah, then we'll just be having something like this. And now we can define it. We can now start using our variance, variance inflation factor. Yeah, from here now, we want to check it on the x values. Then x values. That's when doing it, we want also at the end using for loop, say that for I in range x shape. Okay. Now the point here is like when we are in Python, Okay, the first column, for example, is 0. The second one is 1. And the third one is 2. Here, for example, we are saying that, okay, we want it to come like a data frame. The first column should be called, for example, here, variables. But the second one should be called now VIF. For this, we are using this one, for example. Now that's the point. Then we are just calculating the variance inflation among the values of X, but we want also to shape it. Now, we can run and see if up to now everything is okay. If it's okay, we can just print our result and proceed. There is something saying that, okay, line 9, there is something there. Okay, data frame. You see, it's very sensitive. It should be margins here, cap letter there, but I put small letter, it's bringing me error. We can run again and see what will happen. Everything should come correctly. Now, process finish with exit code 0. That's okay. Then we need now, as I was saying, when we are in Python, when we are just executing whatever, we need to print to see what is happening. And VIF, DF. And from it now, we can now have our result. We can see how our result is look like. That is the point. As we can see, we are just checking on the multi-collinearity among those independent variables which are here: education, experience, NIM, DEEP, and SMSA. They are there. Now, what's the conclusion, or what is those values are saying? When we are using, we are checking on multicollinearity using VIF, the rule is when it is greater than 10%, and when it's greater than 10, the value 10, we are suspecting multicollinearity. But when it's less than 10, now there is no, we cannot suspect anything. And as we can see, education is 1 point something, experience is a 1 point something, NIMDP is a 1 point something. We don't have any problem there. This one is just an intercept. Can you see? It's not our interest here. We are just checking multiple among the independent variables around. Now you can see many things above before to see the result, because Python is just executing things from up to down. Here we are just taking our data to see how it looks like. Hope that this one will help you. For those one who have not yet subscribed, please subscribe. You have a lot of things to line together. And also, if you need to be trained on data analysis, whatever the software, if you want to just use R, Stata, SPSS, or Python, whatever, just you can get in touch with us. Thank you so much. Hope that this one will help you. Subscribe. Thank you so much.